Welcome to Synapse Daily. I am your host. Today, we are traveling back to a year of radical imagination, 1975. The Apollo program had recently ended. Mankind had left footprints on the lunar dust, but the fire of ambition was far from extinguished. While most were looking at the Earth's problems, a group of visionaries at Stanford University and NASA Ames Research Center were looking at the stars not as points of light, but as potential addresses. They asked a question that still haunts our dreams today: if we had to leave Earth, where would we go? Their answer wasn't Mars. It wasn't a base on the moon. It was a massive, self-sustaining city floating in the void. They called it the Stanford Torus. It wasn't just a space station, it was a manifesto for a new era of human civilization. The geometry of survival. Imagine, if you will, standing on a lush, green hillside. You feel the warmth of the sun on your neck. You hear the distant sound of a waterfall. But as you lift your eyes to look at the horizon, something impossible happens. The ground doesn't flatten out or disappear into a hazy distance. It curves upward. It rises into the sky until it is directly above your head. You aren't looking at the heavens, you are looking at the suburbs on the other side of a giant ring. This was the Stanford Torus. A colossal, hollow donut-shaped habitat, nearly 1.8 kilometers in diameter. It was designed to house 10,000 pioneers in a permanent, Earth-like environment. But how do you keep 10,000 people from drifting into the ceiling in zero gravity? How do you create a sky where there is only a vacuum? The secret lies in the spin. To create gravity, the entire torus was designed to rotate at 1 revolution per minute. This rotation creates centrifugal force. To the inhabitants inside, this force is indistinguishable from the gravity we feel on Earth. If you dropped a ball, it would fall to the floor, which was actually the inner hull of the ring. This wasn't just a technical achievement, it was a psychological necessity. Human bodies wither in zero gravity. Our bones soften, our muscles atrophy, and our hearts weaken. The Stanford Torus was a masterclass in biological engineering. By spinning the world, NASA's scientists were literally weaving the fabric of earthly life into the cold fabric of space. Harvesting the moon, the mass driver. But here is the mystery: if the physics worked in 1975 and the blueprints were finished, why are we still sitting on Earth 50 years later? What stopped the construction of the greatest machine ever conceived by man? One of the most mind-blowing aspects of the 1975 summer study was the how. You cannot launch a city from Earth. The weight would be astronomical, the cost would bankrupt the planet. To build a city of 10,000, you need millions of tons of steel, glass, and shielding. So, the engineers looked to our closest neighbor, the moon. The plan involved a mass driver, a giant electromagnetic railgun sitting on the lunar surface. This machine would catapult bags of lunar soil into space, targeting a specific point in orbit called L5. There, a team of spacefaring construction workers would catch the material and process it in solar-powered furnaces. The torus was to be shielded by 5 feet of raw lunar slag. This massive layer of moon dirt would protect the residents from the silent killer of deep space, cosmic radiation. The interior ecosystem, a breath of life. Inside this protective shell, a vibrant ecosystem would be built. This wasn't just a series of rooms, it was a living, breathing biosphere. The internal structure was divided into several distinct tiers. At the outermost level, where the centrifugal force was strongest, sat the residential and agricultural zones. The soil would be several meters deep, allowing for the growth of large trees and intensive crop farming. This wasn't just for aesthetics. A colony of 10,000 people requires a staggering amount of biomass to maintain a breathable atmosphere. The plants were the lungs of the torus. Every leaf was a biological machine scrubbing carbon dioxide and pumping out fresh oxygen. The scientists calculated that the agricultural section alone would need to produce enough soy, wheat, and vegetables to make the colony entirely independent of Earth's supply chains. They even planned for livestock, rabbits and chickens, to provide protein in a high-efficiency cycle. The sunlight would be captured by a massive primary mirror floating above the ring, reflecting natural light down through a series of secondary mirrors into the living areas. By tilting these mirrors, the colony's administration could literally control the time of day. They could simulate a 24-hour cycle, create seasons, or even initiate a storm by adjusting the moisture levels in the air. It was a closed-loop system where every drop of water and every breath of oxygen was recycled with 100% efficiency. Life in Low-G, the hub of innovation. Moving inward toward the central hub, the gravity would gradually decrease. This gradient created unique opportunities for industry and recreation. In the low-G zones near the axis of rotation, residents could engage in activities that are physically impossible on Earth. Imagine a sports stadium located near the central hub. Here, the gravity might be only 10% of Earth's. Athletes could jump 30 feet into the air. Swimmers could dive into pools where the water moves in strange, slow-motion waves, and if they jumped out, they might float for seconds before drifting back down. Human-powered flight, using simple wings attached to the arms, would be a standard weekend hobby. But the hub wasn't just for fun. It was the industrial heart. In the zero-gravity center, factories could manufacture materials that are impossible to create under the thumb of Earth's gravity. Perfect crystals for electronics, ultra-pure alloys, and medicines of incredible complexity. The Stanford Torus was designed to be an economic powerhouse, a Silicon Valley of the stars. The social experiment, a new human story. But let's talk about the people. This wasn't meant to be a military base or a cold laboratory. It was a home. The designs included shopping centers, schools, and theaters. Yet, life in a closed loop requires a different kind of social contract. In a world where one person's waste is another person's oxygen, the level of community responsibility would be unprecedented. There is no away in a space colony. You cannot throw trash out of a window. Every piece of plastic, every scrap of food, and every drop of human waste had to be chemically processed and returned to the system. This required a level of technological reliability that had never been tested. If the recycling pumps failed for even a week, the atmosphere would become toxic. The colony was a living organism, and like any organism, it was vulnerable to both mechanical failure and human error. Why did the dream stall? The 1970s was an era of intense optimism followed by brutal economic reality. The estimated cost of the first Torus was roughly $200 billion in 1975 currency. While that sounds like a lot, it was actually comparable to the cost of the interstate highway system. The real barrier was political. The public's interest in space began to wane after the moon landings. The Cold War shifted focus toward smaller, more immediate military technologies. The dream of a city in the sky was traded for the reality of the space shuttle, a vehicle that could go to orbit but had nowhere to stay once it got there. We built the bus, but we forgot to build the destination. The modern legacy, O'Neill's children. Yet, the legacy of the Stanford Torus lives on. When you look at modern visions of space colonization from companies like Blue Origin or SpaceX, you see the fingerprints of the 1975 study. Gerard O'Neill's work remains the definitive blueprint for orbital living. We are currently seeing a resurgence in O'Neillian thinking. As Earth faces increasing environmental pressures, the idea of moving heavy industry into orbit is being discussed not as a fantasy, but as a survival strategy. What does it do to the human soul to live in a world where up is just another neighborhood? How would a child born in the Stanford Torus, a Taurian, view the flat Earth of their ancestors? They would grow up in a world where the weather is always perfect, and the threat of a storm is just a computer error. It would be a utopia, but a fragile one. Final thoughts. As we look at the stars tonight, remember that for a few years in the 1970s, we had the math, we had the materials, and we had the blueprints to build a new home in the heavens. We chose to stay on the ground. But the plans are still in the archives. The moon is still there, full of the minerals we need. The sun is still shining, providing more energy in a second than we use in a year. The only thing missing is the will to start building. This has been Synapse Daily. The Stanford Torus is a reminder that the future is only limited by the size of our dreams. If we can imagine a city in a ring, we can surely build a future that transcends the boundaries of our home planet. Thank you for joining us on this journey into the high frontier. Stay curious, stay bold, and keep looking up, because one day, Up might just be where your neighbors live.